doing outside ना time reduce होता है wind noise.
नहीं उधर का बहुत आ रहा है.
Hello.
It's just the live has started. हाँ hello. हाँ ठीक है, thank you. Hi GTG. I am getting my energy. Just wait a minute. I am getting my chai actually, guys. I want to have full energy while I teach you. Yes, hello everyone. How are you all doing? Hi everyone. Hello GTG. What is the full form GTG? Got to go. Gotta go. Okay everyone, in this life everyone, we are going to see all the chemical reactions, right? All the chemical reactions of the first chapter, that is your chemical reactions and equations of class 10th, right? The first chapter, and you are scared of all the chemical reactions. See, last time we studied about balancing chemical reactions, right? You can go watch that live as well. You can watch the one shot as well. Everything is there on the channel. Okay, today however we are going to start the types of reaction, right? We know we have 4 types of reaction and we'll study all of them. Good evening everyone. How are you all doing? How are you all? How is your, I won't ask preparation, how is your summer vacations going? Okay, I'll just have small chai with you, okay guys? Okay, so everyone, in this live we are going to see the types of reactions. As you can see, we have 4 types of reactions: combination reaction, displacement reaction, double displacement reaction, and the last one we have, what did I miss? I missed decomposition reaction. So we have combination reaction, decomposition reaction, double decomposition reaction, and displacement reaction. Displacement reaction was the one I missed. Okay, great. We know the names, right? But we want to study them deeply, and what's their impact, their equations, how to balance them, and all that we will see in today's live. Okay, so everyone give me a thumbs up, give me the hearts, so that we can start the live as soon as possible. Okay, show me your attendance, show me your love, so that we can start the excitement, the josh of this chapter. Okay, very good. Now see bacha, we have 4 types of reaction: combination reaction and decomposition reaction, displacement reaction, double displacement reaction. That is done. Now starting with combination reaction, what does the name suggest? You tell me, what does the name suggest? Ma'am, the name suggests is to combine something, right? Combination is to combine something. Now as I'm drinking chai, and as we studied about chai as well, right? In chai we combine lots of ingredients, right? We combine tea leaves, we combine water, we combine milk, and we have this hot tadak bhadak chai, right? That's what we get as our product. So these are reactants, this is product. So every time in a reaction, when we combine 2 or more products, 2 or more reactants, and they are combined and then forms a single product. Remember, we combine 2 or more reactants and a single product is formed, and that bacha is my combination reaction. Okay, we combine tea leaves, we combined water, we combined milk, and a chai is formed. That is my combination reaction. Until now everything is clear, right? Everything is clear. Okay, then moving on to some of the most basic examples of combination reaction, right? Beta, okay, in combination reaction, see, in combination reaction there is one significant thing you will notice is this heat part. So bacha, in this combination reaction, right, you will see that almost all of the times heat is being generated. So whenever heat is being generated, there is majority of the chance, not every time, but there are majority of the chances that this is a combination reaction if you see heat. Okay, Now this is a very important topic, burning of magnesium ribbon. Burning of magnesium ribbon, we'll study about that. Okay, now let's say you have Mg. Okay, now I have an Mg element, right? And this atmosphere has so much oxygen in it, right? The one we breathe, right? The one trees throw out, everything. So that oxygen reacts with magnesium. That oxygen reacts with everything, right? But that oxygen specifically reacts with magnesium, right? So magnesium we had in solid form. Now oxygen from air is reacting with magnesium, right? What it forms? It forms MgO. It forms MgO, which is white in color, and a lot of heat is generated with it. Okay, bacha? A lot of heat is generated with it, right? Now this property, this reaction has some properties, okay, that we are going to see. And beta, this is very important. The direct question in boards will be asked. Question in boards, okay beta? Direct question in boards can be asked from this particular reaction. Okay, done? Now see, whenever magnesium burns with oxygen, it gives so much heat, right? That means it burns very vigorously, right? Whenever magnesium is put up with oxygen, it gets very excited, it burns, right? So it burns with dazzling white flame. So whenever you see magnesium reacting with oxygen, you will see there is a bright white dazzling light is there that is reacting with magnesium. That means magnesium is reacting with oxygen. Understood everyone? Give me a thumbs up. Understood everyone? Great. Now beta, this MgO becomes, right, this Mg plus O2, it becomes what? It becomes MgO, right, and heat. Done? Until this we are clear, right? Until this, why is this eraser not working? Okay, until this is clear, right? Now this MgO powder that is being made, this MgO powder is actually, bacha, it is white in color. It is white in color, and we put it in a watch glass. What is a watch glass? Have you seen watch glasses? Have you guys seen watch glasses? It's kind of a small petri dish, like the one you drink in chai, the one you place under a chai cup, right? Something like that, but a lot smaller, little round from the bottom, right? And it's made up of completely clear glass, so we can watch our material, hence it is called watch glass, right? So a white MgO powder in watch glass is formed, heat energy releases, so temperature increases obviously, right? And then combination and exothermic reaction. Beta, we will study about exothermic reaction, okay? Exothermic reaction is basically in which heat is released. If heat is released, that means that is a exothermic reaction. Understood everyone? Understood everyone? Any doubt in this? You have any doubt in this? Burning of magnesium ribbon. Okay, let's move on to the next then. Okay, great. You guys don't have any doubts. Great. Okay, now bacha, next we have some thing about this magnesium ribbon only, some questions about it. Now these questions are very important, okay? These questions, bacha, these are very important. These will be directly asked in your boards, okay? So we have a question. Why do we rub magnesium with sandpaper? Why do we rub magnesium with sandpaper? See, we just studied this reaction. So what happens? There is a magnesium, right? Magnesium strip. It is placed in an open air. So what will happen? It will get converted into MgO. So to peel away that layer of MgO, we rub this magnesium with sandpaper. Hello Deeksha, welcome to Deeksha channel. How are you? Okay everyone. Okay, now we are doing combination reaction, okay? Inside that combination reaction we are doing burning of magnesium ribbon. Understood? Now they have a question, why do we rub magnesium with sandpaper? So how do you use your brain? You use your brain that, ma'am, we just studied that Mg with oxygen, it becomes MgO. So to get clear Mg, we rub the upper layer of magnesium oxide, that is MgO, right? To remove any layer of MgO already present on the surface of magnesium, and that is why we rub this magnesium ribbon with sandpaper. Okay, hi Vaikunt, how are you guys? Okay bacha, understood? Why do we rub magnesium with sandpaper? Now next question we have, why to keep magnesium ribbon away from your eyes? Now you tell me, if there is heat coming out from something and a dazzling white light coming out of something, will you go near it? Or you stay away? Of course you stay away, right? And that's the property of magnesium. It burns with a dazzling white flame, and this flame beta is so bright, just like we see at sun sometimes, and we won't be able, and we look at something else and we are not able to see the things properly, right? That's what happens with magnesium when it burns. Right? Hello, how are you, ma'am? I am great, Vaikunt. How are you? Hello. Santi? Sorry. What is your, how should I pronounce you? Okay, Santam. I'll call you Santam. Okay, I'm great everyone. How are you all guys? Okay, so we are just done with our magnesium, burning of magnesium ribbon. We saw two very important questions. First is, why do we rub magnesium with sandpaper, and why to keep magnesium ribbon away from your eyes. Now we burn to remove the upper layer of magnesium oxide from magnesium, we rub it with sandpaper, right? And because the reaction is exothermic, because there is lots of heat coming out of this reaction, and it emits dazzling white light, and that light you cannot see for a short time after looking at it. That is why we keep it away from our eyes. Okay, Santi, I'll call you. Okay, great, Santi. Done. So we studied combination reaction. Combination reaction happens when two or more reactants combine together to form a single product. The example was chai, okay, our very beloved example, and our example was what? Burning of magnesium ribbon. Magnesium combines with oxygen from the air and becomes a dazzling white light comes out of it, and it's so bright, it's so heat comes out of it, and we get magnesium oxide. Understood everyone? Understood everyone? Give me a thumbs up so that we can move to the next part. Okay? Okay, great. Now next part, bacha, we have our another example, that is quick lime in water. Last time lots of you guys were asking me to do this reaction, okay? So look carefully, we are going to do. What is this firstly? It is simply, let me use white color, okay? It is simply, bacha, a combination reaction. It is simply a combination reaction. Done. Ma'am, how do you know that? Let's see if I know that or not. Okay, great. Aditya Raj is going very good. Thumbs up. Great. Hi Aditya. Hello Aditya. Okay, great. Okay, hi. So we are doing quick lime in water. Now what is quick lime? That we should know first, right? So CaO, calcium oxide. CaO beta is quick lime. It is your quick lime. Calcium oxide is your quick lime. Understood? Now beta, it is obviously written that we have to react it with water. Now CaO reacting with H2O, what will happen? Beta, this hydrogen wants, I am paired with oxygen, I want more oxygen. I only have one oxygen here. I want more oxygen. So what it does? Here oxygen is 2 times, right? So it goes with, this eraser is not working. So this hydrogen and this H2O combines with CaO because it's a combination reaction. What will becomes calcium, and this water is converted into hydroxide, that is OH. Right? This is converted into OH twice. Now see, is this balanced or not? Ma'am, this is balanced, right? See, the calcium is 1. Calcium is 1 here. Oxygen is 2. Oxygen is 1. 1 oxygen, 2 oxygen. H2, H2. So it is balanced as well. And heat is also being generated. So we understood that if heat is there, 2 reactants are there, 1 product plus heat is there. What is it? It's a combination reaction. Done. Are we itna spam? Yeah, just leave it. Okay. Yes, Deeksha, I will. Don't worry. Okay, if you didn't understand the reactions, just stay here, I'll teach you everything. Okay. Now first is beta quicklime in water. Quicklime is CaO. Ma'am, how will I remember CaO is quicklime? Beta practice. Okay. What do we talk about? Practice in chemistry. Okay. Yes, Santi. We'll do the questions. First, let's understand the theory, okay? The reactions. Okay, so CaO combined with H2O. H2O is feeling very lonely. He wants 1 more oxygen. So he gets combined with CaO, right? And what becomes? Calcium oxide with water becomes calcium hydroxide. And what is that, beta? That is your slaked lime. That is your slaked lime. CaOH twice. That is your slaked lime. Ma'am, how will I remember? Practice. Okay. RV. Hi. You are in 11th. Okay. Nice. PCB. Great, RV. That is great. So you are refreshing your chemistry concepts here. Okay, so after this important reaction, beta, what we have to remember? First, it is a combination reaction. Second, beta, as heat is revealing, it is an exothermic reaction. It is an exothermic reaction. Understood, everyone? Give me a thumbs up. Okay, it is an exothermic reaction. Done? मैम स्लेक्ड लाइम एंड डैश का डिफरेंस बता दो. किसका डिफरेंस बता दो? ओके आरवी, ओके. Wondering YouTube. Great. Okay. Done. How are you finding physics and chemistry? Is it harder than 10th or are you finding it good? Yeah? Okay, so we are in the live, bacha. Okay, great. Now, this is slaked lime. What we did? Quick lime with water makes slaked lime. Okay, slaked is kind of a watery stuff. Okay, now beta, what is this? This is, ma'am, that white cement that we put in our houses, right? So that white cement, when combined with water, if you have ever seen your workers doing, Nana, they'll get that powder, they'll put water and they go back. They're like, oh shoot, there is so much heat generated out of it, so much fumes coming out of it. Okay. Okay, then, okay, let me read. Okay, easy. Physics is kind of easy. Okay, you're finding physics good. That makes me happy. By the way, chemistry is okay, not okay. Yes. Now I'll let you on a little bit secret. When you go to organic chemistry, either you like it a lot, okay, or you won't like it at all. Okay, mostly based on your teachers. I had great chemistry and physics teachers, and I hope you find good teachers as well. Okay, now bacha, what we have? Talking about, yeah. Okay, so we get that white powder, we put water in it, lots of heat come out of it. That white powder is quick lime, and the thing that is being made is slaked lime. Okay, beta. Now this quick lime is solid. This is solid, okay? But this slaked lime, you know, when we put water into something, obviously it's going to be a bit liquidy, right? So this is beta now an aqueous solution. Understood? This is now an aqueous solution. Interesting than 9th. That's great. Hi. Let me read all your names. Hi, Pamela. Pamela, can I call you Pamela? Okay, hi, I'm Pamela. Okay, ma'am, I know this chapter. Okay, then you should revise this chapter as well. Yes, Aditya. Next slide. Okay, let's just go through it. So, see, heat is generated. Obviously, temperature is increasing. So, rise in temperature. Quicklime reacts vigorously with water. I told you, they go away. Lots of heat is generated. Okay, water is added slowly because reaction is exothermic. So, they don't just put the water like splash. Right? They don't do that. They put the water very slowly so that not a vigorous amount of heat generates. Right? And then, of course, it's a combination and exothermic reaction. Quicklime is used in making cements that we talked about. Right? Okay, great. Then chemistry is not interested. Okay, beta. Okay, it's fine. Sometimes not all people like chemistry, right? Okay, great. Now beta, we are moving on to decomposition reaction. Now what we studied in combination reaction? I love biology, you love biology, that's great. Okay everyone, tell me, what did we understand in combination reactions? Ma'am, in combination reactions, we were making chai, we were getting so many reactants, heated it together and made a product, and again heat was generated, right? So we were combining some things, right? In decomposition, we were breaking some things, right? Decomposing means the breaking of substances, okay? Let me call out the decomposition of sometimes the bodies of animals that have died and stuff. So what does the worms decompose on that body? Decompose that body? That means the worms break down that body, right? Similarly, the meaning is same, just there was a body, here are some chemicals only, okay? Okay, you love biology, I understood. Aditya. Okay, now this is a reaction in which a single reactant, we take just one reactant, a single reactant is break down into one or more products. So we have just one thing here, there is just one chemical substance is there and it breaks down into more than one or more products. Basically, this is the decomposition reaction, okay? That is it all. Right? That is why the decomposition reaction, there are three ways. Okay, now we are talking about the ways in which decomposition reactions are happening. Until now it is clear. We just take one reactant and we break it into one or more products. Right? It is opposite of combination. Very good, Sanity. Sanity? Why did I call you Sanity? Sanity. Okay? Okay. Done everyone? Now this is a decomposition reaction. A reaction in which single reactant is broken down into one or more products is called decomposition reaction, right? Now we have different kinds of decomposition, okay? Now beta, you want to break a thing, right? You can use a hammer, right? Or you can use some other tools, right? I don't know how to say those tools, or you can use a drill, right? And you can use all those different kinds of tools. Oh, hi Tejasvi. Okay, just ignore the spammers, okay? Now, there are different kinds of processes in which we can break down our reactant, we can break down a single particular, our solution, our solid, right? First, bacha, is thermal decomposition. Beta, whenever you see thermal means heat. Okay, we use thermal heaters, we use thermals, we use thermos, right? So what are all these substances used in winter? To keep us warm, to keep the water warm, to keep us warm, to keep our room warm. That is, the thermal word is related to heat. Okay, the thermal word, thermal, electrolytic and photochemical decomposition. Very good, Santi. Okay, so first is thermal decomposition. What happens in thermal decomposition? We are breaking a reactant. What do? We use heat, we heat it and break it. That's it. We heat the reactant and we break it into 2 or more substances. We heat the reactant and we break it into 2 or more substances. Okay, these reactions are use the energy in the form of heat for decomposition of the reactant. So beta, this CaCO3, we have CaCO3, calcium carbonate, right? Whenever you heat calcium carbonate, now see, this is only one reactant, there is no plus sign with it, no, nothing is added, right? So only one reactant is there. When you heat it, it breaks into calcium oxide. That was what? That was our quicklime, and carbon dioxide. Okay, so calcium carbonate, bacha, when heated, it breaks into calcium oxide plus carbon dioxide. Done. And this happened due to heat. Okay, this happens due to heating of calcium carbonate. Ma'am, good evening. Hi, Bubu Pradhan ji, good evening. Election लड़ा है प्रधान जी. Kumar, hi Kumar. Okay, done. Very good. Santi, substance is broken with the heat. Okay, great. Now, first, next type of decomposition, bacha, is our electrolysis. Ma'am, what is electrolysis? This is not something we have heard, right? So bacha, electro is what? Electro, from the word electro, you can see electricity. You remember electricity? So that means whenever we have a reactant, always we want to break it. That's our goal for decomposition. So whenever we break the reactant with the help of electricity, by supplying electricity, we give it shocks, and as we give it shocks, the reactants break into 1 or more products. Done. Ma'am, please summarize once. Yeah, Supriya. So basically, let me give you a overview. So see, in the previous lecture, bacha, we saw what a chemical reaction is, right? Simply when 2 or more substances combine together and they make a product, or the 2 or more one substance breaks down into 2 or more products, that is simply a chemical reaction. Okay, there is rearrangement of atoms, change of state, right? We have different properties: change in color, change in state, change in temperature, and evolution of gas. Then we basically just saw what a chemical equation is. It's simply how we write the chemical reactions, right? Chai was the product, so we won't write chai. So simply calcium is being mixed with oxygen and calcium oxide is being made, so we won't write the full word calcium plus oxygen. We'll simply write Ca plus O2 gives CaO, right? That's what we write. So that is what a chemical equation is. So we saw how to balance chemical equations, and we did so many examples. See, we did this example, we balanced this, then we did this, then we practiced all of this. Okay, you can go watch the last live as well. These 2 questions I made you do, these 2 questions as well. These are very important. Then bacha, today we started the types of reactions. We have 4 types of reactions. Good evening Kumar, good evening. Yes, you will get notes after this lecture, okay? We will do it and achieve our goal. Yes, very good, Santi. That's the spirit, that's the josh. So we started 4 types of reactions. The reactions are what, bacha? Combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Combination reaction is where we combine 1 or 2 reactants and a single product is made. Usually it is exothermic, heat is released, right? So those are some substances. We read about burning of magnesium ribbon. Mg with O2 gives MgO. White dazzling flame comes out, so we keep it away from our eyes so as to protect our eyes, and we rub it with sandpaper to remove the extra layer of magnesium oxide from the magnesium. Then we studied about quicklime in water. CaO plus H2O gives CaOH twice plus heat. Again, it is an exothermic. It is used in cement making. We add the water slowly. Quicklime vigorously reacts with water. See, okay? Then rise in temperature, obviously, because heat is generated. Okay, Shankar Pradhan Maharaj. I am from Odisha, Bhubaneswar, and how are you, ma'am? I am great, Boo Boo. Ma'am, would you tell me something about this channel? I'm new. Hi, Supriya. Yeah, hi, Supriya. So basically, we are Deeksha Vedantu, as you know the name. So first of all, we teach completely in English, okay? Because we understand that you have to give the exams in English. So I have to teach you in English as well, right? Now, bacha, and that will improve your communication skills, your further skills in your life for communication if you go out abroad as well, right? Now, and not even outside in India, if you connect with people outside, with lots of good-minded people, you need English, right? That's the truth. Then, bacha, we take science, SST and maths on this channel. We come live on every day for class 9th as well as class 10th. So you can join this channel, you can subscribe this channel, and you can also meet Aditya, who's saying okay. And I am your Aditi Ma'am. Done? Okay. Now quickly let's move on to thermal decomposition. Done. Electrolysis. Now we use electricity to break down the reactant, right? We use electricity to break down the reactant. Now bacha, these reactions involves the use of electrical energy. These reactions involve the use of electrical energy for the decomposition of reactant molecules. Done. Right? Now basically we use this electrolysis to break water. Beta, breaking water is something that is fascinated. It's something that requires lots of energy, right? So we'll study about electrolysis of water as well, okay? So make sure you subscribe to the channel and like this live session, okay? Now, this water molecule, when you supply electricity, I have electrolysis. Do not worry, we'll study about this is electrolysis. But first, let's understand what is this, okay? Let me just get my water. 1 second. Okay. So beta, if we put current into the water, what will happen? You know, we can get electrified, right? But why does that happen? Like, water is not a good conductor of electricity. Actually, water is mixed with some salts or with some acids, then it becomes a good conductor of electricity. Okay, so right now you can learn that whenever we use electrical energy to break down a reactant, it is called electrolysis for decomposition. Now water is broken into hydrogen and oxygen. Okay beta, thank you Deeksha, thank you so much. Yes, Auntie will do the questions, don't worry. Oh, the water is really hot. Okay, next we have the last kind of decomposition, bacha, that is photolysis. Okay, this reaction, see, photo is something you will learn in the next year, not this year. You have learned light, right? So photo, we studied about light, photon, right? So from photo you consider that we are talking about light. So whenever we use light energy to break something, it is called photolysis. Right? It is called photolysis. These reactions involve the use of light energy for the purpose of decomposition. We have AgBr, it's in solid. We put so much light on it. We have AgBr and we go out and ask the sun to put some light on it. And the sun goes, okay madam, let me do that. So it shines lots of sunlight and the AgBr breaks into Ag and Br. Right? And this AgBr is also used in black and white photography. Okay, so which reaction is used in black and white photography? Photolysis. How many types of decompositions are, bacha? Quickly tell me. Oh, thank you Supriya, thank you so much. It's very easy, bacha. You can also learn. You can watch good Hollywood movies and you will learn the accent. You can learn to understand the accent is what I mean. Okay, so you are coming and you try to speak with other people in English as well. Okay, now what I was talking about, 3 kinds of decomposition reaction we have. Very good, Santi. We have 3 kinds of decomposition reaction: electrolysis, photolysis, and bacha, what was that? Thermal decomposition. Right, great. Now let's move on to the very next topic, that was electrolysis of water. That means electrolysis is a part of decomposition. It's a part of decomposition, bacha. Okay, now decomposition means breaking of components, right? Breaking of a single reactant into one or more product. So electrolysis of water, ma'am, that means we can get water from the ocean and break it into hydrogen and oxygen, and we can produce more oxygen. Kind of. Okay, not entirely true, but kind of. Okay. Hi Deeksha, I am actually from Punjab, but right now I am not in Punjab, I am in Bangalore. Okay, but originally I am from Punjab. Okay, great. Now moving back to electrolysis. Now what do? Okay, we take a beaker and we put something that is called anode and cathode. Beta, you will learn about this later, but just understand for now, it's a kind of a road through which we supply electricity, right? Through which we supply electricity into the water. We'll put wires into the water, that's how we give it electricity, right? So those roads, we use roads, and those are called anodes and cathodes. What are those called? Anodes and cathodes. Now remember, anode comes first. See, how do you remember? Anode, A, B, C. These are the alphabets. Anode comes first, A for anode and C for bacha, cathode. Done. Now you just remember that anode comes first, so it will get positive sign. Okay, so it will get positive sign. Cathode comes last, so it will get negative sign. So anode bacha is positively charged. It is positively charged. Cathode bacha is negatively charged, and these are connected with a battery to supply the current. Okay, okay bacha, done. Okay, great. AgBr, yes beta, yes. AgCl, AgBr. See, Br and Cl comes in the same that period of our periodic table, right? So whatever properties are shown by chlorine are mostly shown by Br. So AgBr and AgCl can come under same reaction. Done? Okay. Now bacha, let's move on to understanding the electrolysis. Now what is written? Electrolysis of water is the process of breaking water. Okay, we understood that, into hydrogen and oxygen. So breaking of water into hydrogen and oxygen using electricity. What am I doing here? I am highlighting the keywords just like you have to in your exams. Okay. What is written opposite bacha? What is opposite written? Supriya, ma'am, screen पे opposite लिखा है. What is? Nice to meet you, ma'am. Nice to meet you as well, Deeksha. You should come sometime, meet us. Okay, done. Now bacha, this is basically what? Breaking of water, H2O into hydrogen and oxygen using electricity. Done until this is clear. Now the very important point, ma'am, do you know pure water is not a good conductor of electricity? Pure water means, but ma'am, when I go and touch the water and there is some electricity flow, I'll get the shock, right? You will get the shock. But that is not pure water. Pure water is simply hydrogen and oxygen. The water what we have has so many salts in it, has so many other impurities in it. All those impurities, all those salts are good conductors of electricity. But alone water, if you just have hydrogen, just have oxygen, it won't be a good conductor of electricity. So what we do, we take distilled water, it is called. Okay, we have like big cans of distilled water in our labs. We used to use that for our reactions. Okay, beta, it started at 5 p.m. and it will mostly go up till 6:15. Okay, yes, distilled water, Santi, correct. Hi Anchal, how are you? How are your vacations going, guys? I really want to know. Okay, so you tell me, until then I explain this hydrolysis, I was going to say. Okay, electrolysis of water. Done. So we have a mug, we put some water in it, but that's not what do you say, impure water. Okay, so pure water is not a good conductor of electricity, but we want to pass electricity. So what we do, this, see, pure water is a poor conductor, so we add few drops of dilute sulfuric acid, that means H2SO4, and dilute. So we add some dilute sulfuric acid to make it a good conductor of electricity, so that this electricity actually passes from our water. Okay, now bacha, see, cathode is what we saw, cathode is negative, right? So on the negative part, hydrogen releases when this is water, okay, and electricity broke. Now we have to separate hydrogen and oxygen as well, right? So that is what cathodes and anodes are for. On this cathode, this is cathode, on this cathode all the hydrogen is separated, all the hydrogen comes and sticks to the cathode, okay, all the oxygen sticks onto the anode. Let me use this pen, this different pen for this. Okay, so bacha, this is anode, this is positive, this is cathode, this is negative. Now on the negative part, hydrogen gets stuck, right? Hydrogen gets stuck on the cathode, and on the anode O2 gas gets stuck. So we simply says O2 gas is released, or hydrogen gas is released on cathode. On anode, oxygen gas is released. Okay, that's what we usually say. Done? Ma'am, my vacation is ending, watching your recorded videos. Okay, that's nice, that's nice. Now you think this is very important, right? Ma'am, how can I get notes? I will provide you notes, Supriya, don't worry. After this live session, there will be a PDF in the link and you will get the notes. Okay, don't worry. Everything I've written here, you'll get the notes. Done? You don't have to worry about anything. Okay, great. Now, understood? Now ma'am, how do I remember that hydrogen gets stuck on cathode, oxygen gets stuck on anode? So it's a little trick that I made. Okay, so it's completely mine, you can use it if you want. Okay, now bacha, see, we have studied about CH4, methane, right? Carbon compound CH4, C2H6, C3H8, right? So all those stuff, C and H comes together, right? So from there I remembered that C is cathode, C is cathode, and H is hydrogen. C is cathode and H bacha is hydrogen. That means hydrogen goes to cathode and then oxygen comes to anode, simply. So hydrogen gas is released at cathode, oxygen gas is released at anode. Done? Now, what is the volume of gas? Do you see? Then in H2O, we have 2 molecules of hydrogen and 1 molecule of oxygen. So obviously, double hydrogen gas will released as compared to oxygen. If 1 molecule of oxygen is released, 2 molecules of hydrogen will be released, because water is H2O. So what will be the ratio? The ratio will be 2:1 for hydrogen ratio oxygen. Done, beta? Okay, completely understand, ma'am. Great, very good. Hi Nagendran, how are you, Nagendran? Okay, good. Now we have this very simple reaction, water breaking into H2 and O2, right? So water, let me write it again, H2O, and let's balance it again to crisp up your concepts, okay? H2O gives H2 plus O2. Now you balance it. Now one more thing you can do to actually make a good impact on your teachers, bacha, that is writing that H2 is a gas plus O2 is a gas and H2O is a liquid, beta. H2O is liquid, obviously water is liquid, ma'am, right? So will you be able to balance this? How many of you are balancing this? Let me know. Let me know first. Okay, great. I will see whoever answered. Okay, now see, hydrogen is 2, hydrogen is 2. Okay ma'am, this is balanced. Oxygen is 1, oxygen is 2. Here ma'am, this oxygen is very bad. So what will I do? I can't write this, right? This is not legal, this is illegal. So what we will do, I have to write here. So ma'am, great, oxygen 2, oxygen 2. But ma'am, wait, hydrogen is 2 into 2, 4 now. But here we have only 2 hydrogen. So what? I'll just put a 2 here. That's how you balance. Great. Santi said 2H2O, H2 plus O2. Great. Then, okay. So that was electrolysis, bacha. Breaking of water into hydrogen and oxygen, putting cathode and anode. So at cathode CH4, hydrogen gets stuck, and at anode oxygen gets stuck. Or you will write at cathode hydrogen is released, at anode oxygen is released. Okay, and this is the actual equation. 2H2O breaks into 2H2 plus O2. H2 and O2 are in gas, H2O is in liquid, obviously. Okay, great Meena, great Meena, Supriya, Santi, very good, all of you, great. Okay, now let's move on to the displacement reaction. Now this reaction is really good. I like to explain this in a very fun way. Okay, but it hurts a little bit. Okay, so let's say you are friends with someone. Okay, now I have a bestie, I have a best friend. Okay, and you boys have your gang. Okay, now you have one best friend, and she's really cool with you, he's really cool with you. Now another person, third person comes in your next class, and he or she comes and she has an eye for your best friend, but you're like, sure, no, my best friend is mine and he won't go anywhere. Okay, and she won't leave me, right? But what do you see, after a few days your best friend chooses that person over you. So what did they do? They displaced you and went and sat with someone else. That hurts, right? More reactive matter displaces less reactive metal. Very good, Santi. But did you understand my analogy as well? This is some science language he's talking about. Do you understand my analogy? Great. Now let's talk about in a chemistry point of view. Let's study about the definition and tell me if you understand with my example. Okay, so a reaction in which a more reactive atom or element displaces a less reactive atom or element from its compound. So you and your best friend had a great bonding, some third person came and they snatched your best friend away. So that means your bond was a little less strong, right? Or in strong, the same word for science, as we know, right? The science has a different language in itself. So the strong is reactive. So your bond was less reactive. The new person came, it was more reactive, and it snatched your friend away. What a way of explanation. Thank you. Okay, now you understand. Now you'll remember this for life. You have to. Okay. That means a reaction in which a more reactive atom or element displaces a less reactive atom or element from its compound, from its friendship. Okay? Hi Sandeep, how are you? Done, bacha. Now let's see some examples. For instance, when iron is added to a copper sulfate solution, then what happens? Iron displaces the copper metal. Okay, let's see. A is the new friend. Okay, A is the new friend, and which is what, beta? More reactive. It is more reactive, right? Now B and C already had a good bond. B and C are like best friends, right? They are best friends. But now A is like, I'm more reactive, I have to snatch C away, I like C. Okay, so what happens? C chooses A over B. Now this is a new compound and B is now very sad. Okay, B is now very sad. Yes, miss. Completely understand. Okay. When will the class get over? It will be around 10 10-20 minutes more. Okay, we will do all the chemical reactions today. Okay, and then in the next live we'll do all the questions. Okay, Santi, you have to come in that live and tell me all the answers in that live. I will be waiting for you. Okay. Now, so basically displacement reaction is when A replaces B, right? A came and replaced B, B went out, AC is the new compound. Now, above equation exists when A is more reactive. Now, bacha, let's say another person came and he tried to break your friendship with your best friend, but that your best friend is loyal to you. Oh, he doesn't give bhav to a third person, right? So that means your bond is strong, that person is less reactive, right? That person is less reactive, your bond is more reactive, more strong. Okay, so that then it won't break. Done. Now done. Now let's just see an example. We have Zn plus CuSO4. Now in Zn you can also have iron. Okay, iron plus or Zn. Now what happens, bacha? Iron is stronger than copper. Zinc is stronger than copper. So the compound will be ZnSO4 plus copper will now be alone. And they are happy. Okay. Ma'am, do you have completed basic chemistry on this channel for class 10th? Actually, bacha, this we have just started class 10th, right? Your class 10th just started. How will I complete class chemistry? But there is one shot of the first chapter, that is the basic, and I have one more video, all chemical formulas. So that is the video where you should see to clear your basics of chemistry, right? You'll understand I have given you all the list of all the elements, metals, non-metals according to their reactivity. Okay, so you go study them and you watch that whole video, practice writing formulas. That is most important for the basics of 10th class chemistry. Okay, you watch that video. Done. It is all chemical formulas, something like that. Okay, I'll show you in 2 minutes. I'll show you. Done. So basically, bacha, this iron or zinc, these are more reactive than copper. They kick copper out and now they combine with Zn or FeSO4. Done? On basic of class 9, that will help in class 10. Okay. Supriya, yeah, sure. I'll make one video for that as well. Don't worry. Okay, done? Although you can go watch the video I have already uploaded, it's about chemical formula. That's mostly the basics. It will clear your basics, and then as you go, see, class 10th has so many different kinds of topics in chemistry, right? So every topic is different. So in starting of every chapter, I am clearing your basics only. In this chapter also, we studied how to write chemical reaction, how to balance chemical reaction. See, we did all these examples in the last live. So you can go watch that as well, right? Hi ma'am, this is Nikesh. Hi Nikesh, how are you? How much syllabus have you completed? Or how many web series have you completed in your class 10th? What should I ask you? Done? So we are done with combination reaction, decomposition reaction and displacement reaction. Done? Okay, Supriya. What is the one reaction that is left, guys? We are left with double displacement. Now, your best friend left you, right? And she got away with someone else. Now you got angry and you're like, I will make a new best friend. So you do what? You make best friends with the best friend of the person who snatched your best friend, right? Right, so that is bacha your double displacement reaction. What happens? A and B had a perfectly good bond, right? Then C and D had a perfectly good bond. Both of these are happy, right? Then A was mad. A is like, enough of B. I want to have a friendship with C. And B gets angry and B is like, okay, if you are having friendship with C, I'll go and make friends with D. Okay, so A replaced D and B replaced C, right? What happens? Oh, I said ulta. A replaced C, so A and C made a good bond, and then B is like, okay, I'll go with D, and then B goes and combines with D. So A what do you say, displaces D. It took the position of D and now made a good bond with C. B took the position of C and made a good bond with D. Okay, done. So that, my friend, is your double displacement reaction, DD. Okay, that is your double displacement reaction. What's a great spoken English class? Yeah, okay, I'll teach you English as well. Do you want? Okay, great. Now let's go back to our definition and study if we are right or not. So what happens? A reaction in which two different atoms or groups of atoms are displaced by other atoms or group of atoms. Ma'am, what is this? See, two different groups of atoms are displaced by another two different groups of atoms. That means C and D were two atoms. They were replaced by A and then by D. So two or more group of atoms got displaced by another two or more group of atoms, and that is called a double displacement reaction. A reaction in which two different atoms or groups of atoms are displaced by other atoms or group of atoms. These reactions generally, bacha, occur between two ionic compounds in the solution. So this double displacement reaction, it mostly occurs in a solution. Done? Okay, bacha. Understood, everyone? Double displacement reaction in which one or two different group of atoms, two atoms or group of atoms are displaced by another atom or group of atoms. These reactions generally take place in a solution. Okay, now let's see some examples. Now the very famous example of this is Na2SO4 aqueous. What did we say? Aqueous, it's a solution, and in that same beaker we put BaCl2 as well. So this is also aqueous. So now Na2SO4 and BaCl2, these are combined. What happened? Na2SO4 combined with BaCl2. Both of these are aqueous solutions. Okay. Now in a beaker, you have Na2SO4 and BaCl2. Now Na is like, I don't want to be with SO4 anymore. Yeah, I'll go with Cl. Cl seems more exciting. So it wants to bond with silver. So chlorine. Right? So it wants to bond with chlorine. Where did silver come from? Okay, so this is NaCl. It becomes NaCl. Right? Cl goes with Na. So SO4 and Ba are alone now. So they're like, okay, we can be friends. So one more bond becomes, that is BaSO4. Now can you balance this equation? Understood? This is what, bacha? This is double displacement reaction. This is double displacement reaction. Done? And beta, can you balance this equation now? Can you balance this equation? Now you might ask, ma'am, why did Na go with Cl? It could have gone with Ba as well, right? So, bacha, for that we need ionic composition, right? Na is plus, Cl is negative, SO4 is negative, Ba is plus. See, okay, this is plus, this is negative, this is negative, this is plus. So obviously the plus will go with minus, right? Plus will not go with plus only, correct? Okay, hi, unknown. Ma'am, what is aqueous solution? Beta, aqueous solution, aqueous is aqueous, okay? Aqueous solution is liquidy, watery solution, okay? It is mostly liquid solution. Done? Anyone has any doubt? Let me know. Done? Okay, great. Done? See, but the aqueous solution, liquid can be anything, okay? Liquid can be anything. there are some substances which are completely liquid, some acids which don't have water in it are completely aqueous, liquid substances, right? Aqueous on the other hand, bacha, aqueous is where the main solvent, you have studied about solvent in 9th class, right? So solvent is water, we add something, so a water, salt in water is an aqueous solution, right? That is an aqueous solution. But H2OSO4, which doesn't have water in it, a concentrated H2SO4, that is liquid. Okay? Okay, great, no doubt. Good, good, good. Done? So this is your double displacement reaction. I asked you to balance this. Who among you can balance this equation? Let me know. You have 30 seconds. You have 30 seconds to balance this equation, and you will write answer in comments. Whoever will see the recorded version, the answer will be in the comments. You guys will write the answer in the comments. Okay? Okay, we have the balanced. Meena has gave the balanced Na2SO4 plus BaCl2. Na2SO4 plus BaCl2 gives 2 NaCl, okay, and BaSO4. That's it. Okay, let's see. Na2, 2 Na. SO4, S1. We have S1, SO4, 1. Okay. Ba1, Ba1, Cl2, Cl2. That's great. Very good, Meena. Very good. Who gave the answer? Meena. Meena gave the answer. The first one is Meena. Who will be the second one? Meena is the first one who gave the answer. Who will be the second one, my friends? Okay. Okay, I'll write the name. Whoever gives the answer second. Until then, let's move to the next topic, beta. That is what? That is simply a difference between displacement reaction and a double displacement reaction. We studied, and this will be asked in your exams. This is very important. Okay, bacha, this is very important. Now look carefully. In a single displacement reaction, this is a chemical reaction in which one more reactive element that replaces a less reactive element. Understood? Right? In double displacement, however, it is a chemical reaction in which two ionic species, ionic species, you know, which have positive or negative sign on them, right? They have one extra or one less electron, cation, anion, right? Okay, these are exchanged between two molecules. So in this, the A is exchanged by D and B is exchanged by C. Done? Okay. Next we have general formula. So A and B had a good bond. C came and took the position of A. So now A is left alone. B and C have a good bond. But here A, B and C, D are there. So B is replaced by C. So A and C becomes a good bond. B and D becomes a good bond. Understood? And the last is no precipitate formed. We'll study about precipitate in a minute. Okay, we have Supriya as the second. Okay, I will write that Supriya gave the answer on second. Supriya is second, first is Meena. Very good, both of them. You will get a smiley from me. Okay? Okay, then next we have bacha precipitation reaction. Now ma'am, what is precipitation reaction? Precipitation reaction, we never heard of precipitation reaction. Okay, okay, you have water, okay, and you are putting salt in it. Just an example. It's actually a different example, but you will understand better from this. Okay, you have water and you're putting salt on it, and it is mixing, but you keep on putting salt. Okay, so you are continuously putting salt in your water. Will the salt dissolve? Any amount of salt you put in your 1 glass of water, will it keep on dissolving? No, right? At one point will come where the salt will start settling down. Right? It will start settling down at the surface of your glass. That is something called precipitate. The substance that gets settled down in a solution is called a precipitate. What is a precipitation reaction? Precipitation reaction occur when cations and anions in an aqueous solution combine to form an insoluble ionic solid. So we are mixing two stuffs together, two solutions together, right? And we see it is giving a product that is insoluble. Insoluble means it is settling down, right? Maybe powdery, maybe solid. So it is settling down at the bottom, and it is an ionic what? It is an ionic solid. Because it is settling down. If it was liquid, we wouldn't have known, right? It is an insoluble ionic solid. Okay, great. Rosh is saying hi. Hi, Rosh. Okay, that is what our precipitate is. Precipitation reaction is a reaction in which cations and anions in an aqueous solution, they combine to form an insoluble ionic solid. That is my precipitation reaction. And that insoluble ionic solid is what, bacha? This is our precipitate. Let me write it a little more clear. This is our precipitate. Done, bacha? Understood this one? Till here understood, right? Okay, now let's see a very important thing, that is the example of this. Now understand, we saw in double displacement that Na2SO4 and BaCl2 both are aqueous solutions. They combine together, they form BaSO4 and NaCl. Right? Now beta, this BaSO4 is actually our precipitate. It is of white color, precipitate. And whenever you mix this NaCl with our NaSO4 with our BaCl, this example is a little different. So whenever you mix Na2SO4 with BaCl2, you get BaSO4, that is our insoluble solid, that is of white color. That is what? That is a precipitate. Understood? Understood, everyone? So we are clear with precipitation reaction and what a precipitate is. Now let's move to the last point. What is this? No precipitate is formed as a result of color change. So in displacement reaction, bacha, mostly color change happens and there is no precipitate formed. Okay. On the other hand, on double displacement reaction, in double displacement reaction, we see that precipitates are formed. This reaction is an example of double displacement, right? This is a double displacement. So this BaSO4 is our precipitate. It is our precipitate and it is of white color. What? BaSO4. Understood? So these are the examples of double displacement reaction. That is our precipitation reaction. Done? And that is it. Bacha, we have two more, that is exothermic. So beta, exothermic is the reaction in which so much heat is released. So much heat is released and as a result temperature increases of the surroundings. If lots of heat is coming out of me, the surrounding will get heated, right? So temperature increases of the surrounding and heat is coming out of it, right? So combination reaction is mostly exothermic. Similarly, we have endothermic reaction. Endothermic, the heat is absorbed, it enters into the body. Endothermic, it exits the body. Exothermic, heat is entering, so that is endothermic reaction, right? Correct? Now decomposition reaction, the reactant that breaks into two or more parts is endothermic reaction. Done, bacha? And we have two more topics. Okay, let me just quickly complete them. We have oxidation, bacha. Whenever in any compound if oxygen is added, right? In any compound, if oxygen is added, addition of oxygen is called oxidation or losing of electrons. Two definitions are there. Addition of oxygens, C plus O2, CO2, addition of oxygen, and loss of electrons. Loss of electrons happens if I give 2 electrons, that means oxidation happens. Aditi Ma'am's oxidation happened. Okay, or removal of hydrogen. If I take oxygen or if I give hydrogen, that is oxidation. Done, bacha? Yes, ma'am. Yes, Supriya. So this leads to increase in oxidation state. So bacha, this is Zn. Its oxidation state is 0 now. Okay, if it loses 2 electrons, it becomes Zn2 positive, right? It has 2 more positive charges and plus 2 electrons. So its oxidation change state is increasing from 0 to +2. It's increasing, right? So that means oxidation state increases in oxidation. Addition of oxygen, losing of electrons or losing of hydrogen is called oxidation. Then now bacha, we have very important thing, that is oxidizing agent. Oxidizing agents are those substances which can oxidize other substances. What does this mean? So whatever helped me get oxidized, whatever helped me lose electrons, whatever helped me gain electrons, whatever helped me lose hydrogen, that thing is called an oxidizing agent. Why? Because it oxidized me. And bacha, okay, let's study about reducing agent first. Ma'am, it's 6:12. When will your over? Just in 5 minutes. Okay, just give me 5 minutes more and the class will be over. Okay. Now bacha, we have reduction. This is the last topic we'll study today. Last topic. In the next week live we will be doing the questions. Okay, and one more topic is left, rancidity and corrosion. We'll do in that lecture only. Okay, now bacha, reduction is addition of hydrogen, losing of electrons and addition of electrons. Okay, slow down. Addition of hydrogen, C plus 2H2 CH4. So with carbon, hydrogen is added, right? So that is addition of hydrogen. Or removal of oxygen. If I remove oxygen from me, that means reduction happened. And if I gain electrons, I had space for 2 electrons, right? So 2 electrons came and I gained those, so I become a normal with oxidation state 0. So oxidation state is what? It is decreasing here. It is decreasing here. So oxidation state will decrease in reduction. And what is reducing agent? Simply the thing that helped me gain hydrogen or lose oxygen or gain electrons, that thing is called a reducing agent because it helped me reduce, right? Now see, in oxidation bacha, what happened? I am losing electrons. Those electrons are gained by what? This reducing agent. So I am losing electrons, this agent is gaining electrons. So gaining electron is what? Reduction. Losing electrons is oxidation. So in me oxidation happened, but in this thing reduction happened, right? Understood? Okay, great. Okay everyone, that is it. Next class will be bacha in the next week only. Okay, tomorrow is Sunday. Have fun. Next week you will have the planner by Monday. There is a link in the description. Go join that WhatsApp channel, subscribe this channel. We are scheduling the whole week's lives 1 week prior. Okay, so on Monday you will know when will be my class, when will be SST's class, when will be maths class, so you can plan accordingly. Okay bacha. Oxidizing agent, yes, 1 second. Okay, so beta, what will happen? See, this is Zn plus 2, right? Zn, we had simply Zn. Okay, we have Zn, and what happens? Zn is becoming plus 2 electron, right? Now Zn is sitting, it won't as usually lose electrons, like give your electrons. Okay, it gave its electrons, right? There is something, let's say, called let's say A. So this A helped Zn to lose electrons, right? So this A that helped to oxidize zinc, right? A helped oxidizing zinc, right? So this A actually helped oxidizing zinc. So this A becomes an agent. It becomes an agent that helped oxidizing zinc. So then A is my oxidizing agent because it helped to oxidize zinc. Done? Understood? Okay bacha. Similarly we have reduction, reducing agent. Okay bacha, that is it for this class. I will see you in the next one. Subscribe this channel, like this session if you like this live session. Okay, I am your Aditi Ma'am and I'll meet you in the next live. Okay, bye bye, tata, bye everyone.